Hi, this is Rick for EDU Mobile. Today we're going to talk about an important design pattern for Android applications called Model View Controller. And it is more than a design pattern. It is actually a design philosophy that Android adopts as an organizational philosophy for Android apps. So this is very important, and it will inform everything we do in the course to a greater or lesser degree. So let's go ahead and get started. The Model View Controller pattern is a high-level design pattern for software development, and this exists not only in Android, but in software development as a whole. In Model View, object-oriented development, I should say, in Model View Controller, the classes are categorized according to function. So model classes basically are what an app is. It's data representation. What does this app represent? What is the data I will be working on? So model classes are a representation of the data for the application. View classes are how a user interacts with your app. Views are the user interface. Controller classes are what exists between the model and the view. Controller classes control the view controls, and they also send messages between the model and view classes. So let's look at this in a little bit more detail, and I want to start with the controller. A controller will instantiate the view, and it will handle all user interaction with the view. It will set label text, it will handle view events, and so forth. So everything that happens on the view is done to a greater or lesser extent by the controller. The controller also instantiates the model, and it passes messages from the view to the model and from the model to the view. The important thing here is that the model and view don't communicate directly with one another. They always communicate through the controller. In Android, controllers are really the activities, not the layout XML that goes with the activities, but the activity class itself is a controller. So an Android service, then, we talked about services in the last unit a little bit, and we'll talk about them a great deal more, but an Android service is like a controller with a model, but without a view. So services don't have a view, so they're not really a view controller, but they do have a model, even if it's just embedded within the controller. So that's something we'll mention a little bit later. So now the view is instantiated and owned by a controller. We can think of this in Android as the layout XML for a particular activity being the view, and the activity itself being the controller. It never communicates directly with the data that is represented by the user interface, which is the model. So even though the data is displayed for the user on the view, and even though the user may think that the view is all there is to an application, there's really more going on behind the scenes. The view tells the controller what to send to the model, let's say, or the controller gets that information from the view and sends it to the model. The model may update itself in response to some order from the controller, and then the controller will send the updated information to the view. So, but there is never a direct line of communication within the model or from the model to the view or vice versa. This is very important, and I keep saying it, but it's extremely important. In Android, views are best represented by the layout XML files and the controls within them. Now, even if a controller defines its own view in code, even if we don't use a layout XML and create a view dynamically in code, the controller has still instantiated a separate view, and it's the same concept. So the view is separate from the controller, even if it's instantiated within the controller. So there is a distinction between the view and its controller. In other words, the controller's view is a separate object from the controller. The model, simple. Model encapsulates the data for a controller and a controller's views. It handles all the data for the application. It never communicates directly with a view. And I think that's probably the last time I'm going to say that today. but you'll hear it over and over from me. Views and models don't communicate to one another. They use a controller. A good model hides its own implementation. So what do I mean by that? Well, the controller knows about the model, but it doesn't necessarily know how the model gets the job done. So in our demo, we send a string to the model. The model does something with it, and then later we ask for another string from the model, and the model gives it back. What happens in the middle is unimportant to the controller. The controller knows what it wants. The model is the thing that implements the action that the controller wants. So a good model hides that implementation. So let's have an example. This example is very simple. It's adding an element to an array. So we assume that a view has a text control that allows a user to enter a string, and the view also displays a list of strings somehow that have already been entered. So let's look at the steps that have to happen. So first of all, the user enters a string. And let's say that already in our list we have hello there, and now the user has entered Android. The controller says, hey, that's new. I want that. And so the controller gets the string. The third step, the controller sends the string to the model. Here, do something with this. So our red dot here represents the string Android. And so the model says, oh, okay, I know what to do with that. Internally, I'm going to add that to an array. So I've already got hello and there that we've displayed in the view. So now I'm adding the string Android. So internally, I know what to do with that. So then the controller requests the data. Do you have new data for me? And the model says, yep, I've got something for you. Now, how that data is represented, the model sends it back. The controller asks for data in a particular fashion. The model knows how to package that data and send it to the controller in that fashion. And finally, the controller displays the new data in a list, which is a view implementation. But the controller knows what the view wants and sends it out to the view as a list. And now we still have the string Android in the view, so the controller tells it to clear the input control. This is a very simple example of the interactions between a model, a view, and a controller in any application. But what we're going to see is a demo of how this happens, essentially this same example in Android. Thank you very much.